Hello, it's Mr. Leung here, and then we are going to previously we have talked about 1.1 to 1.3, and definitely I will have more video for the different landform and different hazards for the play boundary and then also the opportunity and risks in the play boundary. Then to move on, then I would like to talk about the tectonic hazards first. Okay, then first of all, earthquake. Then do bear in mind that the difference between epicenter and the focus. Epicenter is right in the land surface. Okay, right in the land surface. But for the focus, it's really the point that happening the earthquake. Okay, the source of earthquake we call as focus, which is more or less in the most most of the time is in the underground. Okay, then first of all, what is earthquake? As I have shown you in the lesson, then you should know it's a sudden shaking of the land. Okay, but why it's going to occur? First of all, you have to tell, oh, time after time there's a lot of pressure in between the pay boundary or the area next to the pay boundary, and then the stress is accumulated because of this kind of pay movement and or the force involved in the pay movement. Then the stress is most of the time is accumulated. Then energy will build up in the rock layer, and then until it really cannot stand, until it's exceed the limit of the rock or strength of rock. Okay, the fracture will be formed, and once the energy exceeds the strength of rock, the rock will break down along the fractures. Then the release of energy stored in the rock beneath the Earth's surface caused an earthquake, and seismic wave will be released. Okay, so accordingly, it's definitely having a higher destruction because it's more adjacent to the epicenter or adjacent to the focus. Okay, yeah. Then distribution of earthquake, yeah, and more or less alike with the Pacific Ring of Fire, but and also you have to taking care about the this one, okay, which is the Alpine Himalayan belts, okay, and also some of them will take place in the constructive pay boundary or the hotspot, but not really that far, or also the minor pay boundary. That's where we are not going to mention in our syllabus, but yeah, you should know that in an for example here, okay, the East African Rift Valley, then you should know in the lesson I've introduced the Somalian belt and also the Arabian belt to you, plates, Somalian plates and also the Arabian plates to you, okay, during the East African Rift Valley explanation. Okay, then yeah, it's also around the minor plates and also links to the construction place boundary, not really much, but still have some. Then accordingly, then mainly is mainly along the pay boundaries, mainly also the play convergent and transform pay boundary. Constructive is not really that much, okay, because there's a great stress and also the energy is built up more easily and rapidly, okay, as I mentioned, circumferential belts and also Alpine Himalayan belt, okay. Interior of the place, because most of the time there may be some faulting or the minor place boundary that is haven't mentioned in here, hotspots as well as I've mentioned, okay, yeah. This is an important skill since it may take place in the DBQ and you are being asked for describing the global spatial distribution of earthquake or the volcanoes eruption or the tsunami. Okay, you will also need to explain like this way. Okay, once you are having the roadmap, and then you're gonna tell me what is the distribution, what is the spatial distribution of the different pace boundary. Okay, then next, depth of focus. Okay, what are the relationship between the depth of focus and also the earthquake? First of all, the if for the convergent pay boundary, because there are subduction, there may be the earthquake under deep underground, okay, deep underground. So both shallow and also the deep earthquake will taking place, okay, because yeah, right here is also having some pressure, and then once the pressure, once the plate is going down into the mantle, is well down, and then the pressure will also build up the area next to the pay boundary. Okay, so the shallow earthquake will occur in the diverge and transform faults. Okay, diverge and transform pay boundary, because it's just the breaking and also the sliding past the lateral force will mainly taking place in the shallow just right below the ground surface. Okay, then subduction of plates will also cause friction or integrate depth, and then therefore it generate the intermediate and deep focus earthquake. Then how about long subduction? Will be mainly the shallow focus earthquake. Okay, then mainly the shallow earthquake is more dangerous, but the deep earthquake are less damaging. Okay, next then this is case about 311 earthquake in Japan, which I have always asked you to have a good look about this, and you can provide a lot of examples in the essay. Then it's just a recap, then I'm not really going to talk about it. Remember the Richter scale, remember the days that's happening, remember the epicenter, which is quite adjacent to Sendai City, Shintai. Okay, yeah, and also not really far away from Tokyo. Okay, so you can see the damage is strong. Okay, for the focus, luckily it's 24.4 km, but most of the time you can see it's just 15 or 13 km in deep in the ground surface. Then right now it's not that destructive already, because it's more deeper than the usual destructive pay boundary earthquake. Okay, yeah, a lot of people death and then a lot of injuries, and then I've always told the tsunami wave may up to 14.5 meters. Okay, then why is going to have big earthquake happening in Japan? Mainly because there are lots of boundary stairs. Okay, and also mainly Pacific Pay boundary collide with North American plates, so on and so forth. Okay, then yeah, for here I will have another video to talk about this. But in general, I think you can tell. Okay, yeah, I think it should be Russian plates. Okay, yeah, I make a mistake here, so please change it. Okay, Russian, it should be Russian. Okay. Russian plate should be, yeah. But you should know it because it's not the very ad hoc thing I'm going to tell. I have told you a lot of times already. Okay, how about volcanic eruption? Volcanic eruption mainly in the convergent and divergent pay boundary. Bear in mind, not in the right here doesn't have, okay, the St. Andreas Fault, which is known as the conservative pay boundary, are not having any kinds of volcanic eruption. Okay, then mainly taking place in the convergent pay boundary and also divergent pay boundary. Okay, since it's the Pacific Ring of Fire. Okay, so accordingly, there's a lot of convergent pay boundary, then water released the subduction plates caused the part of the asthenosphere to melt into the magma. When the cracks is developed, because all the way the destructive pay boundary as well as the constructive pay boundary is moving towards them there, and then the magma will rise through the cracks and cause the volcanic eruption. Okay, volcanic eruption, and other examples that is having a lot of volcanic eruption will be hotspot. Okay, hotspot is mainly the mantle plume. I think I have told you a lot of time what is mantle plume. Bloop, 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 bloop. Okay, which is right in the stronger mantle plume. Okay, which is the stronger convection current is generated here, and then if the Earth, if the plate is suffering from a stronger mantle plume, it may break down, and then the magma will rise through along the line of weakness or cracks. Then we'll call it as the hotspot as well. Okay, then the mantle plume touches the lithosphere, as I've mentioned before. Magma push into the cracks and erupt at the Earth's surface. Submarine volcanoes or volcanic island will be occurred. Okay, then yeah, then time after time the magma is cut off because because originally it's just like this, but time after time, since the place is moving, okay, maybe moving this way, I don't know, okay, but you know what I mean, okay, just like a sewing machine, as I have mentioned in the lesson, okay, then the place will moving this side, and then the mental problem maybe start to affect here, okay, affect here, time after time, okay, then yeah, it will form a series of volcano like this, okay, yeah, formally by the northwest side of the Hawaiian island, we can find a series of dormant volcano or even the extinct volcano along here. Is because all the hotspot situation, because the place is moving, but the mantle plumb of the mantle is not moving. So accordingly, there will be a series of the volcanoes developing along the hotspot, okay, forming a line like okay. Then yeah, so I'm not going to tell you one by one, just some additional information and also the how to say, the annotated diagram, okay. So for here I will also explain in another video as well, okay, yeah. Then for the place that's created the tsunami, where we can find a tsunami mainly, what are the difference between the earthquake and tsunami? You at least have to add this, okay, yeah, a series of the big sea wave, and then accordingly it can also be formed caused by submarine earthquake, submarine volcanic eruption, and also submarine landslide, okay, all together. Then it's going to having a lot of tsunami, and also it's still the tsunami is taking place next to the Pacific Ring of Fire, okay. So you can have a look about this, and I think personally the you're gonna remember the Disla Japanese tsunami, and also the Indian Ocean tsunami is important, which can facilitate your essay writing. Yeah, and also be reminded that the casualties of Japan 311 earthquake is 50,000 people, and then wow, for the Indian Ocean 230,000 people. Okay, so what why the different earthquake will cause the tsunami, then or the volcanic eruption cause the tsunami? I'm not going to talk about it here, then you can have a look here, okay, yeah. But the most important thing, indeed, you can just tell me, oh, on top of earthquake, you can just say, oh, it's a vertical displacement of water, okay, yeah. Then mainly it is taking place in a convergent plate boundary. I missed the circle here. Then yeah, it's also again telling you because the circle moved through here. Sorry, yeah. So you can have a look about this, about the general distribution, about the tsunami, earthquake, and also volcanic eruption. Okay, next, this is just the summary that I'm not going to recap again. Okay, yeah, the destruction of the tectonic hazards, just like the I've showed you the different kinds of impact of different kinds of tectonic hazards in this table. So I think this one is enough already, but don't just remember the tag. Okay, yeah, you're gonna remember here. Okay, what is it about acid rain? Toxic gas is belongs to volcanoes. This kind of thing you're gonna remember. Okay, which should be your page 6, isn't it? Page 6, yeah, page 6. Okay, yeah. Then you're gonna remember this. Then let's move on to the 1.5. Then yeah, 1.5. Okay, right here. Then how destructive is the earthquake? Mainly kill and injure the people, damage structure, and water pipe, gas pipe is broken. It's mostly primary effect. Okay, shock people and cause panic among them. Okay, secondary impact effect may include the fires, okay, because the earthquake may not directly cause the fire, but breaking of the gas pipe will cause the fire, and then the water supply is no good, and then it may contaminate the water supply and cause the disease, landslide, flooding, okay, disruption of the communication link, this kind of thing will be regarded as the secondary impact, okay, secondary effect, okay, yeah. Then it's also the explanation that how we can going to relieve it. First of all, seismic seismograph. Okay, you I think you have still remember what is seismograph. Okay, during the earthquake, you always see a machine doing like this. Okay, yeah, 地震儀. Okay, then seismograph is fell into this category, and then yeah, the satellites and also remote sensing, it can also monitor the earthquake to give time for the citizen to evacuate. Okay, yeah. How about the hazard-proof structure? Then maybe we can design the oh, this one is loosened. Okay, sorry. Okay, this one is gone already. Sorry. Okay, yeah, because at the finally because of the page number, I gonna delete some picture. This is the one I have deleted. Sorry. Okay, but you know already in your handwritten notes already. Okay, yeah, you should have the picture in the handwritten notes previously. You have to fill in the blanks one by one. Then on that one you already have it. Okay, hazard-proof structure then is talking about, oh, it can reduce the injuries and also the deaths. Okay, for example, the 101, the damper in the Taipei 101. Okay, I have showed you since the form 3, so I think you should familiar with this. Okay, yeah, damper. Okay, then hazard land use planning. It may include a hazard zone map to help the government plan and formulate the policies for reducing impact of the tectonic hazards. Okay, yeah, for example, those horrible thing, just like the nuclear plant and also the oil depot, please don't put in the coastal area again. Okay, yeah, just like the Fukushima nuclear power plant. Originally, it have planned with some seawall 4 meter, but yeah, it's not tall enough to withstand the 40 meters 311 tsunami. So it's going to be broken. Then yeah. But somehow land use planning have been implemented already, but it's not enough only. Okay, and also when you go to Japan, you can see a lot of evacuation routes during the in the NTL station, metro stations, so on and so forth. And also when you go to the Osaka Castle Peak, Nagoya Castle Peak, then you can find a lot of parks. And also inside the park, you can find a lot of evacuation routes as well. Designate the school and also the in-store stadium as a shelters center is the more or less the similar practice like Hong Kong. Okay, yeah. When you are too cold, then you may go to the community center. Then the Japan's school and in-store stadium also serve the similar function. Okay, yeah. And for the education and drills, it can raise the awareness of the people about earthquake. Okay, for example, Japan all the way is having a lot of earthquake drills, just like we are having fire drills. Okay, but maybe Japanese is doing in a more intensive way. Okay, rescue system reduce the number of deaths, and then rescue teams are well trained and well equipped using advanced equipment. Disaster aid and insurance can rebuild the economy, then also it can reduce the loss in terms of the economy. Okay, how about the volcanic eruption? Then for volcanic eruption, you're gonna be specified about the 3 kinds of how say the emittant or kinds of the things that's coming out from the volcanoes. Okay, which include lava, volcanic ash, and gases, and also the rock fragment. Okay, yeah, which may more or less alike with the lava, because if it's cools and solidified, it may become a rock fragment already. Okay, then the lava may burn the crops and vegetation. The structure may be damaged, causing injuries and death. And volcanic eruption more or less the same, but be careful about the mud flow, which is a bit different with the lava already. Okay, and then the people with difficult with the volcanic ash contaminated air, then also it may block the sunlight and lower the visibility, which may affect the air traffic. Okay, it may also bury the farmland and cause the crop failure as well for the volcanic ash. How about the gas? Mostly it is acidic, so it may also facilitate the acid rain. Okay, I've talked about it. The sulfur dioxide, when you mix it with water, indeed is a sulfuric acid. Sulfuric acid is 強水 indeed. Okay, so it's a bit horrible, okay, and then it may damage the eyes and also the respiratory system, just like the lungs, okay, yeah, so and also it may directly kill the people lah, okay, yeah, so all together it may again cause the landslide, earthquake, and also tsunami even, okay. Then how about this also the recap lah, but how about what about the factors that may affect the destructive hazards? This is the thing that I haven't written in the notes, okay, previous one, that is from the textbook publisher. Then yeah, this one you're gonna have a recap about this, okay. If the duration is longer, then the resistance of the people and also the structure to the hazards will become lower, okay. Let's imagine if the building can stand for 1 hour earthquake, but 1 minute earthquake, but how about we are going to have 1 hour? Then all the things will cannot stand it, okay. Distance from the source, okay, just like maybe you have heard this in the see this in the former Haiti earthquake and also Haiti earthquake. Then yeah, you can see the which is the 2012 past paper. Then yeah, you can see the capital of Haiti is just right next to the epicenter. So the energy of the seismic wave will not be dissipated that much, okay? Then the longer distance of these from the source of hazards, the less the destruction, okay? Yeah. How about the path along the hazard travel, okay? Just like the tsunami, okay? Yeah, tsunami may not be in the area that have been passed through, just like, oh, if the tsunami taking place in the Indian Ocean, oh, how about the Indian island? Okay, they may suffer, but it's not the end. They may also travel to the area that's passing through next to the island. Okay, so it is talking about the hazards, the path passing through. Okay, yeah. How about the time of occurrence? Maybe in the midnight they're sleeping, or also the rush hour also no good because there's a lot of heavy pedestrian or traffic flow. Okay, then yeah, for the volcanic eruption thing, yeah, you're gonna also having the monitoring and warning system to deal with. Okay, yeah, but mainly it's going to study the geological structure and also the history of the volcano. But you may ask seismograph, is this useful? One is put next to the volcanic volcanoes and please specify to check out the tectonic activities next to the volcanoes, then it is useful. But not we suggest you to write down seismograph only. Maybe you can also tell me about the history and also the geological structure of the volcanoes. Okay, yeah. Then hazard-proof structure, building barriers, just like I've told you. Oh, when I'm going to climb the Mountain Fujiyama, there's a lot of barriers as well as the lava diversion channel, which may help to divert the flow of the magma away from the densely popular area just like the Tokyo. Okay, then build roof with the strong structure and also steep sloping sides also can help to shed the ash to prevent the roof from collapsing. Okay, you can find a lot of steep sloping sides of the sided roof or in Japan, okay, because it is going to help the roof from collapsing. Okay, land use planning, the emergency evacuation plan according to the risk level. Then also building important structure can also reduce the can make the evacuation routes become more smooth. Okay, education and drill. Okay, yeah. Then I've told you the what's that? The volcano about the Sakurajima next to the Kagoshima, okay, which is in the Kyushu of the Japan. Then yeah, teaching the people evacuation routes and also make a emergency plan and prepare on the emergency kit, just like the student right there is wearing helmet to school instead of the cap. Okay, yeah, the disaster drills doing regularly, then it is also going to have other measures may include a well-trained rescue team and also the insurance that I've talked about it in the earthquake already. Then yeah, tsunami include this kind of impact lah. Then I'm not going to tell you one by one. Okay, yeah, just the differences, casualty, you know lah, infrastructure, you know lah, transport network, you know lah, building are damaged, you know lah. But you can say, oh, the ship will be stranded or overturned on the land. Okay, the social order may be deteriorated. The coastal area are flooded. The coastline is changed. It's hard to carry out the event project because all gone. Most of the time, tsunami will be all gone. Malaria easily to spread out. Okay, economic loss be strong and psychological impact is strong. Okay, so on and so forth. Then this also the recap of the previous looks. Okay, then yeah, for here maybe we can use the tsunami balls. Don't just say the seismograph, this kind of thing. Too annoying, okay, somehow. And also the ocean bottom, not bottom, ocean bottom tsunami gauges, okay, to monitor the tsunami, okay, which is talking about the things that is under the sea, on the seabed, and checking out the vibration of the seabed. Okay, then it can be transmit the signal to the boils, and then the boils will transmit the signal back to the cities, then maybe asking them to leave earlier. Then the examples may include the Indian Ocean tsunami warning system, but just having 15 or 14 boils only。 OK， 淨係得14個15個浮標嘅啫。Indian 嗰個 OK， 即係南亞大海嘯之後發生嗰個 ，which is going to set up right after the South the Indian Ocean tsunami. OK, but the Pacific Tsunami Warning Center is better because there are 70 boils. OK, which is you can compare and contrast between these two. Okay, these two warning system, then yeah, Pacific Tsunami Warning Center is better, is well prepared than the Indian, because Indian Ocean, you know, most of the time they are having the LDC only. Okay, then the Pacific Tsunami is set up by the United States, and this is having more capital resource. Okay, yeah, mitigation measures just like the hazard-proof structure, then vertical evacuation routes of the coastal structure. Then yeah, we may have some evacuation routes is set up, construct the seawall just like the Fukushima nuclear power plant, but sadly it's just 4 meters, cannot stand the 311 earthquake. Then encourage the people move from the coastal area to the low to the higher ground. It should be, sorry, okay, this wrong. This wrong. Should be the higher ground. 黐線嘅，唔知點解揀咗 lower ground. Okay, then design a coastal belt for beaches and also woodland reserve. Build the evacuation route leading to higher ground. Okay, then also do more tsunami evacuation drill, and then teach people about the evacuation routes. Okay, again, rescue team, and then insurance. Okay, yeah, it's also the well elaborated version of the measures. So maybe you can have a look on your own. Okay, yeah. Then how to evacuate. But what I want to tell is about the evaluation of the measures. Okay, as I've said before, if we are MDC, more technology, more capital, more stable government orders, to make it happen. Okay, but indeed the advanced equipment may not be always accurate. Okay, yeah. Then sometimes the suddenly, just like Hong Kong Observatory have provide such a error also. Okay, suddenly indicated that tsunami warning is going to happen in Hong Kong, but finally not happen. Or then this the kind of human error. Okay, then also involve capital, as I said before, but some of the government may lack of capital, or they are not very well prosperous in terms of their budget, then they cannot really to adopt the things easily. Okay, and maybe they are having the low administrative efficiency. Okay, so these are the different evaluation and also the limitation. So in your last part of the DBQ, then you can make good use of this. Then you can elaborate more. Okay, for example, those monitoring system, it is good to reduce raise the arrest of the people and reduce the number of the casualties, and the people can leave early accordingly. Then, but the prediction may not be accurate. Then also we need other auxiliary services, just like the land use planning. Okay, as I've said in the essay, sample essay going through section, yeah, when you have monitoring system, then you also need to convince supported by the land use planning. When you are talking about the land use planning, then you also need to convince and also supplemented by the monitoring and also predicting system all the way. Okay, yeah. For the mapping, then you may not you may need GIS, remote sensing, and also global positioning system. Then they can be better prepared for the possible future. But again, it needs a high degree of the professional knowledge and practice. Okay, land use planning, I have showed you in the sample essay already. Then yeah, you can handle this. Okay, yeah, I'm not going to mention that long. Then you can have a look about your sample essay, education and drills. But they can also, it's also about the awareness. The awareness can be enhanced, but they need active participation of the public. Okay, improve the building design and also regulation. Then yeah, it is also can reduce the casualties, but again, high capital level, high knowledge, and also need a high efficient government, highly efficient government. Then insurance, again, economic loss can be reduced. Yeah, then also the poor people may not afford the cost. Okay, yeah, so on so forth. I'm not going to tell you one by one because later on the things that may not really happen in the DSE before, so that I just ask, so pardon me to skip it. Okay, yeah. Then this is also the different statistic of the people of the country that may be useful for you. Okay, for example, United States total population, population density, and then China population density, Japan population density. Well, you can see Japan population density is very, very large. Okay, yeah, very, very high. Okay, then it's also factors that may affect the casualties or the how say the degree of the hazards. Okay, that is causing the damage. Okay, yeah. So this is also the things that is in the notes that I have given before, so I'm not going to tell you detailedly, yeah, because it's just the things that I have said before as well. Okay, yeah, this is also the cases which is talking about the comparison between the Haiti and also the New Zealand. Then yeah, Haiti is LDC, then yeah, it is having more damage, and then for the New Zealand is a kind of MDC, and they are having the similar magnitude of the earthquake, but finally the depth is different, totally different. Wow, it's very horrible, very horrible, how say, very horrible casualties, but for here, almost no casualties. Okay, yeah. So this is the difference between the Haiti and also the New Zealand. Okay, yeah. This is also the when you are talking about the measures, then yeah, it may also affected by the exact location, and because if it's the exact location can be precisely predicted, then the people can leave earlier than the impact of the tectonic hazards can be reduced. Strong magnitude of the tectonic hazards also cause the capacity of the technology level introduced that will be affected as well. Okay, yeah, protection area of the tectonic measures, which may include the protection coverage of the technological measures, just like LDC, it is not going to cover that extensive. Okay, then the impact of the hazards can be strong. Technological level, if the level is low, then the impact of the LDC is wrong. Okay, efficiency of the government. If corruption taking place, then it is going to have a lot of lower efficiency. The efficiency is generally low, and then the investment capital will be generally low as well. The maintenance, lack of maintenance. Okay, then the technological measures will be not really good. Okay, because if the technological maintenance is not well maintained, if the data is not well maintained in the 101, then it may fall down. Then it's also a devastating situation. Okay, capital available, no money, no talk. Okay, yeah, it may require a large amount of capital then to prepare for the preventive measures. Awareness of people. If the awareness and preparedness of the people is low, then it's always having a stronger earthquake. Okay, let's go to 1.6 and the risk of the people living in the hazard prone area will mainly include, they may have a very low awareness, and based on past experience, they are not going to die, so they are keep living in there. And then religious background, okay, just like Japan, even Japan also worship the mountain Fujiyama so much, okay, then it's also going to talk about, they may still live in there all the way, okay. How about the socio-economic status? If the country is poor, they really cannot do anything, and they are too poor to move and also too poor to prepare any kinds of thing to get ready for the hazards. Okay, the character of the person, maybe they are very introverted and they are not really going to receive a lot of information, or they are very traditional and then they are not willing to move. Okay, they also is going to affect the planning of the land use. Okay, confidence of the government and modern technology dealing with hazards. Okay, if more modern technology, then it's better. But opportunities, because although there's a lot of risk, but there are also some opportunities, forcing the the resident to living in there. So in order to obtain the opportunity next to the hazards. Okay, for example, the job opportunities in Japan, Tokyo, and wealth of there. So it can also improve the living standard of the people. So it's not really going to have a lot of it's not going to have a lot of incentive for the people moving away, because a lot of incentive is right there to attracting to stay there. Okay, yeah, the opportunities of the hazard prone area maybe include the volcano itself. Okay, yeah. Mainly in volcano itself, okay, earthquake, tsunami will not have that kind of initiate incentive, right? Because next to the volcanic region, there are hot spring and also geysers, which favor the development of the tourist industry. Okay, then geothermal power. Okay, yeah, it may also facilitate the geothermal power, volcanic ash, and also the whether the solidified lava also provide fertile soil for farming. So you may find a lot of good farm produce in Japan. It's mainly because in general, the Japan is really facilitated by the volcanic ash erupted from their volcanoes, and then it can provide a fertile soil. Okay, metals and minerals, okay, such as iron ore, okay, which is always all the way finding in the volcanic regions, and then we can find a lot of precious stones, just like the diamonds, okay, in the volcanic prone area, volcanoes prone area. Social and cultural land, maybe they are really 身土不移, okay, they really love their motherland, or they are the ancestors, all their friends or relatives and their own cultures, and just like Hong Kong, some of the Hong Kong people are migrating, but most of the Hong Kong people are staying here right now, okay, mainly because of this, okay, and also the political barrier, maybe they are not allowed to migrate, okay, yeah, especially in the poor countries, okay, they may implement some harsh policy, then it may also disallowing the people to leave, okay, physical constraint, just like the Himalayas area is very, very hilly and it's hard for them to move. Okay, maybe it's too dry, too cold, or too wet, or for the people to leave. Okay, then you gonna override all the opportunities with the risks have to override the opportunity in order to make the people to leave. Okay, yeah, and also this is more detailed explanation. Yeah, you can refer to it as well. Okay, yeah, flow good climate lah, fertile soil lah, scenic spots for volcanism lah, volcanic features lah, just like the hot spring lah. Yeah, and then beautiful landscape lah, just like Mountain Fujiyama is very good, and then Flow Mountain, I've told you in the lesson, is also very good. Then Mr. Leung want to go to Tibet to have a look about the mountain Himalayas. Okay, yeah. Then also Mountain Everest. Sorry, Yeah, and then the geothermal power, we can use it in the Iceland and also New Zealand. Okay, minerals. Okay, social ties, we have talked about this before, and then the political factors, then strict policy of the population migration, maybe the personal factors also affect that much. Okay, so this brings to the end of the second part of the CP1 essay. So I know it's a bit long, but if you really go and miss the points that I have made in the lesson, then you can really refer to here, and you are very good in order to withstand my poor English and until here. Okay, yeah. Add oil in your examination or test by